As global challenges continue to put pressure on the industry, it will have to increasingly look for partnering opportunities to drive innovation through collaboration through the value chain, industry, and academia. The title of our next presentation is Facing Today's Challenges Through Innovation and Sustainable Solutions. Please join me in welcoming Mr. Patrick Thomas, CEO of Bayer Materials Science. Mr. Thomas is also president of the European Plastics Manufacturers Association, Plastics Europe, and chairman of the Oxford University Business Economics Program Board. Since October 2013, he has been the chairman of the World Plastics Council. Please welcome Mr. Patrick Thomas.
Thank you very much, Nadine. So, Your Excellencies, distinguished guests, ladies and gentlemen, I'm delighted to be here at the 9th GPCA, where we have also taken the opportunity to hold back-to-back the meeting of the World Plastics Council, which Nadine mentioned towards the end of her introduction. I have to correct one thing in her introduction, and that is that I am no longer the chairman of that group, but I'm delighted to announce that Mosaid Al-Ohali, who is the Executive Vice President of Polymers at SABIC, has now taken that role, and I'm pleased to see that SABIC, as one of the biggest plastic producers in the planet, is now leading this very important World Plastics Council. So please join me when you see him in congratulating him on his new position. As Andrew said a little earlier, Andrew Liveris said, there are the haves and the have-nots. And I guess I come from a part of the world which is a have-not. And the age of sustainability is clearly upon us. So I thought it would be interesting to join these two themes together, being a have-not, with the theme of sustainability, and maybe some thoughts about how we can move forward with innovation in our chemical industry over the next 10, 20 years. I think the age of sustainability is upon us, but we've been talking about it, or talking around it at least, for many years. But I believe that the pressure that is now coming to bear from consumers, from society, and from government is about to explode. Everywhere we look today, we feel the pulse of sustainability, particularly, though, with our customers, suppliers, and legislators. And maybe as somebody who is driven by the market, driven by consumers of electronic devices, I have to say that I am driven by companies like Apple, companies like IKEA, companies that drive innovation in consumer goods to provide materials that have a lower carbon footprint than they are used to. When we make an iPhone 5S, we consume 70 kilograms of carbon in its manufacturing process. When we make it out of a plastic material, polycarbonate, the 5C, we consume approximately 12 kilograms less of carbon. That is something that matters now to consumers. There are websites that will tell you the exact carbon footprint of just about every domestic electronic device. So what does this mean for our industry over the next 10 to 25 years? Is it simply another fad that will evaporate with subsequent generations? Or is it indeed something that we're really going to have to understand so that we can truly solve and tackle the problems that society has been causing for many years? We know that the world is changing. The growing and aging population, climate change and scarce resource, urbanization and mobility. Those trends and the resulting challenges will not simply go away, and therefore I firmly believe it is the latter and the resulting needs that will shape the agenda of our industries. We, the chemical industry, have a huge role to play in this. There is a need to shape entire value chains and industries. The chemical industry acts as the enabler through its operations and products and applications, and energy is at the core a huge issue. We must continue to reduce our dependence upon carbon-based fuel systems. We must continue to develop new processes that allow the continuation of the dramatic reductions in energy consumption. We at Biomaterial Science aim to reduce our total specific CO2 emissions by 40% by the year 2020 compared to 2005. When in 2005 we sat down to set a target, we set a target of 20%. 3 years later we had achieved that target, and then 3 years later we set a target of 30%. More recently we set a target of 40%, and I can tell you today I am changing that target to 50% by 2020. That is because we already know how to surpass this target of 40%. We achieve this through such technological breakthroughs as gas phase phosphogenations for making HDI and TDI, and our oxygen depolarized cathode technology that delivers 50% energy reduction in chlorine manufacture. But actually this is not enough. We must continuously invest in new formulations and product developments to assist the renewable energy industry achieve parity with fossil-based energy. Energy from the sun, wind and water will be the future. It will be part of the energy mix, and we develop new materials to drive the use of those renewables. New coatings, adhesives, lightweight structural components for wind blades, just for example, will ultimately have the effect of the economies of wind energy, and the chemical industry is at the heart of all of this technology. The third and potentially most powerful contribution of the polymer industry towards addressing the world's energy dilemma, besides enabling novel energy generation and reducing our own energy consumption in production, lies in reducing energy consumption during the lifetime of our products. Polyurethane is a very high-performing insulating material. When we invest polyurethane into the insulation of a refrigerator, it pays for its carbon invested over 70 times in the life of that refrigerator device. And in this respect, biomaterial science puts a great emphasis on continuously increasing the thermal insulation properties of its rigid foams to increase energy in buildings, construction, appliances, and the cold chain. These last two elements, the appliance industry and the cold chain, not only improve energy balance, but also help to address the challenges for food supply to a growing population in an urbanizing world. Another prominent example in this respect is our quest for super lightweight material solutions that will be needed in evolving or novel transportation systems. BMS does not design these materials solely in a laboratory condition, but looks for real projects where we can demonstrate and test the viability of these solutions. We invest in the Solar Impulse project that will start its round-the-world flight without any fuel, starting and finishing near here in Abu Dhabi next year. We make the lightweight solutions to make a dream come true. In addition to alternative energy supply and energy efficiency, we also need to invest in alternative raw materials that allow easier recyclability, as well as providing an alternative to oil-based feedstock. A great example of this is in the use of carbon dioxide in flexible polyurethane foams. This is a dramatic breakthrough in C1 chemistry, and the possibilities of this catalysis that is thrown up by this invention is huge and exciting. If we can capture and reuse vast quantities of carbon dioxide in the future, we have every possibility of closing the carbon loop. And this is incredibly important in the area of recycling. For recycling carbon will be the biggest contribution industry can make to tackling the climate problem. In macroeconomic terms, we have all witnessed the rise and effect of China during the last 20 years. The country's dramatic growth has had a cost attached to it, and cities like Shanghai and Beijing now feel that effect through air quality and the air quality that they have to endure. But China is not finished and has publicly stated its intent to move towards renewables and to ensure it takes leadership in the green revolution. To be frank, I have no doubt that the country will succeed. We have now also seen the macroeconomic effects of shale gas in the USA as this reinvigorates manufacturing. This too will have an effect on the global economy as cheap exports will take their toll on Europe and other regions. It is becoming increasingly certain that regional manufacturing specialization awaits the industry in the years ahead, and the players who succeed in this game will need to make some extremely difficult decisions. So is all this bad news for our industry? No, I do not think so. It is inevitable, and therefore we have to adapt to succeed. Out of every adversity comes improvement, and I am confident that this will be the outcome as society adapts to this flavor of sustainability. Many of our customers are reporting significant interest in the composition of products and the consumer demand for products with reduced carbon footprint. This is not a bad thing. It is simply a challenge that we have to address and solve. At Biomaterial Science, we're taking an integrated view of sustainability and have built sustainability concepts into our innovation strategy. We develop targets based on a comprehensive view of the benefit or impact of our action on people, the planet, but also on profit. We fundamentally believe that we as a company will enjoy a sustainable economic success if we contribute to solutions that serve people and the planet, thereby creating macroeconomic value of which we will be allowed to capture a good share. And this requires a very full view of the full life cycle of our products. When I talked earlier about the Apple iPhone and the amount of carbon dioxide that it takes to make the iPhone, I didn't talk about the amount of carbon dioxide taken to operate the iPhone during its lifetime. During a normal use of an iPhone during 1 year, or any other mobile device, you're actually consuming more energy than the refrigerator in your home. Through the contribution of energy consumption through the network, the servers, the data highways that are being used by mobile telephony, you're actually using more energy than the refrigerator in your home. Historically, the refrigerator was the biggest single energy consumer in your house. That has now been replaced by your mobile device. We fundamentally believe that we as a company will enjoy a sustainable economic success when we contribute to solutions that serve planet and people. This comprehensive view of the full life cycle of our products is key to that understanding. And because individual companies or individual technologies will not find all the solutions to these challenges as they have in the past, we see that sustainability also transforms the way in which we innovate. Through cooperation and collaboration with academia and across value chains and industries, it also pushes us to think more across disciplines, fostering the value of cooperations with research institutes right across the globe. By doing all of this, we will generate a trust in our industry. We will be able to serve the changing society that is our market and hopefully live up to its technological dreams that will make a decisive difference. The question remains, can the chemical industry live up to its dreams? And here is my personal collection of important technological challenges for the chemical industry looking forward. Let me say a few words about these challenges to give you some idea about what the next decades will bring. We will focus in on C1 chemistry as carbon dioxide ceases to be a waste material and becomes an important and valued resource. We will build new polymers out of different building blocks using C1 chemistry that will have new properties. We will use those polymer building blocks together with new catalysts to create economic processes that are more viable than any traditional chemical processes that we have been involved in. The bio-based feedstocks will compete not because they are green, but because they will be more economic. And organosheets may be a term that is not fully familiar to you. Organosheets is where we bring composite materials together with polymers and produce materials that can be thermoformed into the bodies of cars and vehicles at a weight level that is half that of aluminium, but with significantly greater strength and with 1/4 of the carbon footprint. Functional films will be crucial to our personal devices and our home and how we entertain ourselves and generate information and transfer of information. And barrier properties, which will be higher in polymers than that currently exists using glass, will be crucial to mobile devices and to flexible components that will be important in the future. Thank you for sharing in my dream, and I look forward to collaborating with you, with your academic institutes, and with your companies in the future as we develop this dream together. Thank you very much.